Paul. So we just talked about woody plant encroachment. I just had a cookie encroach right here. So we'll see how we can do this afternoon with all that sugar hitting the system. So when I'm not creating AI images of silly landscapes, I'm asking AI silly questions that may have a serious answer. I threw to my favorite AI the question, what does the Edwards Plateau look like in 100 years? It's a pretty interesting thing to think about. Of course, being AI, it throws out some stuff that makes sense and some stuff that does not make as much sense. One possibility, one scenario is a challenging future. Climate change impacts, some of the stuff that we just talked about, droughts and wildfires, have altered the landscape. You all just learned that they already are and already have, leaving scars on the land. Water scarcity, competition for water resources intensifies. We're already there, leading to a potential conflict, hopefully not there yet, and economic challenges. Urban sprawl, definitely already there. Uncontrolled development encroaches on natural habitats, fragmenting ecosystems. So this is one scenario that feels pretty plausible. A second one was very intriguing to me. A technological wonderland in Edwards Plateau. Geoengineering solutions, innovative technologies, mitigate climate change. Mitigate is an interesting word here. Carbon capture, solar radiation management, which is kind of terrifying if you know a whole lot behind the science of that. Advanced agriculture, vertical farming, hydroponics, abundant food in urban areas, sustainable infrastructure, smart cities, resource use, reducing waste and pollution. That sounds interesting. Something that maybe somebody from 4 or 5 decades ago would have thought about maybe where we are today. A few shows like, I don't know, Jetsons, Star Trek, weird things like that. Here's an interesting, maybe kind of middle-ish path. The third scenario that this AI threw out was a sustainable future. Eco-friendly development. Sustainable cities and towns blend seamlessly with the natural landscape, prioritizing renewable energy and green infrastructure. Interesting. Seeing kind of maybe flavors of parts of those start to work in some of our regional conversations. Flourishing ecosystems. Reforestation efforts have restored native plant species. Wildlife populations thrive in protected areas. Also interesting. Also interesting what native plant species even means when your baseline conditions are changing quite a bit. And then the last component of this is advanced agriculture. Precision agricultural techniques maximize crop yields while minimizing environmental impact. Interesting. So just for kicks, I asked, okay, what would these look like? Here is our challenging future. Ah! But guess what? Optimistic take. I see some moisture right there. The second one, this is our technological wonderland. I guess that's Tower of the Americas 2.0. And then here's what I thought a sustainable Edwards Plateau would look like in 2125. Pretty weird. Maybe we got multiple towers of the Americas. I don't know. This stuff is funny. I'm trying to wake you up after lunch. But one of the things that we can do to help us figure out which path to take and move us down certain directions is understanding. We've learned a lot from Dr. Young, Dr. Wilcox, the complexities and the big need to dive into the nuance because there's not an answer. And I think you've heard multiple times whenever somebody poses a question that feels like it's simple and we want to know the answer to, there's so many different flavors and layers to kind of work through that really depend sometimes on a small spatial scale, sometimes on a very small time scale, what the answers could be or are. One of the things that we can do is to really invest and jump in a lot more into the science, while also recognizing that there is a ton of nuance and complexity. Recent study-ish that I thought is pretty interesting looks at some of these questions in a roundabout way, talks about ecohydrological decoupling. So when systems start to take beatings, whether it be from fire or drought, we can logically come up with what would be the consequences in terms of landscape and water resources. Well, It depends. That is such a big answer and a big part of what these conversations are going to be. Essentially, to kind of boil it down to one figure, is it depends on how severe a disturbance is. How bad is a drought or a fire? How much area does that event cause? Does it impact a small part of your landscape or a big one? And then, how often does that happen? If we've got ecosystems, plant communities, water resources, soil resources that are, I'll say, used to certain conditions, and then those conditions, whether gradually or rapidly change, that disconnect is going to mean other things will start to change too, sometimes in unexpected timelines. And some of the ways that systems have worked in the past and do work now will probably surprise us. So even some of the things that we take for granted, and if you turn knob A, knob B goes this way, we might things start to kind of diverge. So T here is transpiration. So the relationship between transpiration, T, and Q, stream flow, can change. So even some of the stories that we're talking about today, if we have repeat and severe and widespread disturbance, even some of these complex relationships that we're just starting to get to understanding, they might start to get a little hairier themselves. So all this requires tons of monitoring, tons of research to really understand the what ifs here. Another thing we can do, in addition to this constant investment in science, understanding the story, is to start doing things ourselves. It's a relatively recent paper, again, I find pretty interesting. If we do certain things to soil, maybe some of those impacts can be pushed back for a little bit. And this one sounds pretty applicable to this area. Drought and heat waves in dryland tree juveniles. We've got small trees around here. We have drought and we have heat waves here. We're in a dry land. This one, weirdly enough, is actually using amendments derived from shellfish exoskeletons to actually build resilience in soil. It's a gee whiz approach, but they found it has impacts. What other things are out there? That is a big mystery, but something that we can maybe start to play with. At the same time, in addition to these interventions, I think there's a space to broadly re-envision what it means to be resilient. This one actually came out a few years ago and is an antique because it is no longer being produced. This was FEMA's guidance of building community resilience with nature-based solutions. I checked as of 2 days ago, it is not on the internet anymore. But the content is still out there. Also, for right now, FEMA is also still available. We'll see. And they were also riding the wave, and are riding the wave of conversations that have been going on in a much broader space. Because the idea of nature-based solutions, I think, is a current iteration of, Brad, you talked about, what'd you call it, just land management 101? Ideas that have been in the ether for quite some time. And if you look right now, just last night did a search on Google Scholar, show me nature-based solutions. 17,000 results this year. So people are talking using this language. What can we do to interact with our landscape in a way that more reflects natural processes rather than taking a really hard interventionist approach? Even Texas Water Development Board at their conference a couple months ago had, for the very first time, a whole session, you've seen this dude before, on ecosystem services. So as the state plans its water supply, but also flood planning future, what space do we carve out for natural infrastructure, natural processes, and ecosystem services? So this very much is a conversation that's reverberating from the lower levels all the way up to the federal and internationally. And on that international approach, a friend of mine named Todd Bridges, he spun up the Engineering with Nature program out of the U.S. Army Corps of Engineers, is still kicking into that in a different capacity. A couple years ago, there was an international guidance document for nature-based solutions. And his take as an engineer was, When we develop infrastructure for the future, it's an important opportunity to make more intentional use of the processes and functions found in natural systems, strengthen engineering performance, and expand infrastructure value. Now, you can very much hear the engineering speak in that. And he and I have a friendly give and take about how much do you engineer like nature, and how much do you just do nature. We have a friendly dialogue about that one. But in this international guidance document, they borrowed from a thought that had been preceding them by quite some time. It says, in the act of conquering nature, our ancestors too often treated the earth contemptuously, under the delusion that the losses didn't matter, since modern man, through science and intervention, would soon fabricate an artificial world infinitely more wonderful than the one that nature provided. An even grosser delusion. So we've had modern engineering for a couple centuries now. I live and do a lot of the work that I do in the Houston area, which I argue, and by most measures, actually has the highest concentration of engineers in the world, between the civil, the oil and gas, the aerospace, the medical, computer science, all of the engineers. Thankfully, you never hear about water issues coming from the Houston area. That was very much a sarcastic statement. But you can see that if we try the same thing over and over, even with tons of resources, we're not getting the same responses or the answers, the responses that we would like to see. Maybe try something a little bit different. So this is really where nature-based solutions has been embraced in a lot of different ways. And not just because it's fun, it feels good, but because time and time again, with a lot of tools that are pending out now, it makes economic sense. It really does, in a lot of different settings. One of the ways that the levers are being pulled to do nature-based solutions is in the flooding space. Because frankly, talked a little bit over lunch with my table mates about federal programs and disaster recovery. A lot of the dollars right now that flow through different projects are because of extreme events after flooding. There are tangible rules with numbers that you can actually do projects around and write benefit to cost analysis and ratios that come up and justify economic stories. Well, okay, that's one. And as a result, you've got good resources like this that are actually combinations and collaborations between big nonprofits like the Nature Conservancy and landscape architects and the American Society for Civil Engineers. So real cross-discipline collaborations here. And they do things from the site scale. This one is kind of fun because it's kind of a menu, a buffet of different ways that you could actually go about doing nature-based solutions in the flood planning space. Site scale, neighborhood scale, and then at the community scale. There's some overlap, obviously, but as Michael and Brad really talked about, scaling up really becomes important, not just because of the physics of how gravity works on water and watersheds and catchments, but your tools that become feasible at bigger and bigger scales or become less feasible. So understanding what is the appropriate fit for different size, that's all a very important part of the planning conversation. Then you get fun things like this where you might do different interventions at different parts in a watershed. But I see this and say, okay, I see some people throw in nature-based solutions on a landscape. Man, what about these spots? People aren't really thinking about where the big areas to do things actually are. Most of them are folding in elements in already developed areas, or maybe doing some stuff right on a coastal fringe. Coastal space is really big on these right now, again, because that's where a lot of dollars are, because that's where expensive real estate is that people want to wrestle into the ground to defend. But it doesn't have to wait to that point. I think if we take a thoughtful approach to do things higher in watersheds, upstream, but especially of urban areas, with a thoughtful approach, we might be on to something that could be really fun, really good with lots of different benefits. Again, here's conceptually the spectrum of where engineering and nature-based solutions kind of overlap, but again, it's always around flooding so far. I'm actually part of a work group in the agricultural space that's going to be leaning into nature-based solutions in more rural settings, kind of folding into that context too. We'll see where we can push things. But what I would say is there is a nexus here. It doesn't have to be just flooding. In nature-based solutions, we can use some of these solutions and strategies to mitigate things like what we are familiar with a little bit more. Extreme heat. Believe it or not, cities like I don't know, Phoenix are actually developing urban tree canopy plans? Maybe. We're going to be needing to get so much more value out of every single drop, gallon, pick a volumetric measure of water to help us be more resilient in our communities. So extreme heat could be one. Also, wildfire. And science is getting pretty solid that one of the biggest drivers of wildfire risk is not just wind, yes, but soil moisture as well. So for our soil physicists that want to make soil sexy, there's nothing as being sexy as being on fire. Except when it's this kind. Wildfire risk, believe it or not, is actually one of the biggest things in Texas, and it's one of the things that nobody's talking about until we do. We've all experienced maybe pictures or videos of some a decade ago, but this is actually one of the biggest growing risks in Texas, not just from the science perspective, but from the insurance perspective. This is the thing that's actually freaking out insurance providers the most in Texas, because it's not just along a coast, it's not just along rivers, it covers a big area. So, what can we do with water to reduce risks of extreme heat and wildfire? One of the ways, too, new science, it was about a year ago, showing how we use water in a landscape can actually be one of our biggest buffers towards extreme heat. When you're already in kind of an undeveloped landscape, your ability for water and green space isn't going to be huge, but when you're in a developed context, every spot where you can put a pocket of water and vegetation, especially this end, you might be talking 20 degrees difference, 25. This one is from an average of resources around the world, but in my neck of the woods in the Houston area, urban tree canopy prairies as well, not just the trees, but the prairie grasses in town can mean a difference of 15 to 25 degrees during the summer. And we always think it's, oh yeah, the shade really helps us out. That is a piece of it. But the actual biggest driver, as Michael was talking about, is what happens when water gets turned from a liquid into a gas. That's where actually the cooling happens, is it turns these water resources essentially into our outdoor air conditioner. So if we can slow water down and keep it in places, it can do things like sustain trees that provide some shade, keep them healthy so they're not as susceptible to drought and to wildfire, but then also provide cooling a little bit for all of us. So there are ways that we can plug in nature-based solutions and get benefits even if they're not in the flooding space. But again, kind of talking about this phrase, I think it actually goes back to somebody that I learned from even before I learned from Dr. Wilcox years ago. A gentleman named Stephen Whisenant. Dr. Whisenant literally wrote the book on repairing damaged wildlands. It's a very process-based approach. So it's understanding how things interact with each other and then kind of choosing a path forward based on those relationships, not just because everything is the same, but it's all about the difference and the details from site to site. What makes water work, what makes soil work, what makes vegetation work in specific areas, understanding that almost from a forensic approach, and then mapping a trajectory to something very different. So there is a nature-based solutions kind of element to it, but it's things that we've really been talking about for a long time if you talk to the right people who are really students of the land, of the world around us, who are just steeped in taking observations and understanding, taking the time to understand how things work, not just from a hunch or a gut, but spending a lot of time to collect data and to just watch. So when we think about actually taking steps to do things a little bit differently, we've got to start with one thing that we've already talked about is the geologic diversity just of Texas. This is, in general, the geologic units. You can see that it's kind of like a tilted layer cake from the northwest down to the coast, thanks to a whole lot of long-term history and things moving around via rivers and water. And if you zoom in to where we're at right now, you can tell that there's quite a bit of diversity right here, just in this county and then all the way around the escarpment. So again, big reflection of what has gone on in the past for deep, deep time. But that's just geology. I'm going to pull a couple of soil maps here from the USDA showing that Even within those big pockets that themselves are incredibly diverse, then you've got little soil series that can change from here to there that themselves are radically different, mean different things for what we can expect and do and get in response. So this is electrical conductivity, essentially how well can it be like a battery. I don't really want you to get focused too much on what the numbers mean, so much as the incredible diversity over small scales. So even within one county, there's a whole lot of difference. This is surface texture, how much sand, silt, and clay, lots of difference. A lot of it maps on to the geology. This one is interesting, though. For some reason, none of Berg County is good for crawfish aquaculture. Very strange. That is actually one of the criteria that they map out at USDA, probably because we're in a karst landscape and very darn dry. But if you look at things like depth to restrictive layers, this could be to really hard rock or to groundwater. Lots of variance there. And then this is called an ecological site. Because of all these different things about soil, maybe where it's at, landscape position, general rainfall, what is kind of the expected ecological site? And if you've ever taken a field ecology or even geology or pick a class, you've gone out and to see pictures similar to what Dr. Wilcox shared previously of generally these landscapes look this way. This way, they have trajectories they can change, but you can tell when you're in different places. And even within Berg County, there is quite a bit of intrinsic diversity, largely driven by the soil and then the geology. This one is erodibility. I feel like this one is one that we can very much embrace when we're talking about nature-based solutions, because everything you do to impact water could hurt or could help this erosion story. I think we're going to hear a little bit about that this afternoon too, because with the best intentions, we want to move water in certain directions, and we always forget about the soil part of it. And water doesn't just move by itself, it carries everything that it's strong enough to carry, and a lot of times that means bringing soil with it, and that causes sometimes even bigger problems than the original one that we were trying to solve. Available water supply, this is how much water is in a soil column based on texture and rocks and things like that. Want to finish up here with a couple. Talked about infiltration rate. Again, lots of diversity based on what the soil, what the geology are. This is infiltration rate at the surface layer. I'm going to throw another one at you, kind of similar. So this is, again, just at the top. How fast can water get in just at the top? And this is all layers. You can see that there's difference. And this is based on soil profile, even if they look similar at the top, based on how deep they are, some subsurface differences, those can even change. And I'm showing you this because difference, site conditions mean the world. They have everything to do with what solution you might propose, whether your project might be successful or not. And these just are kind of based on the expected baseline conditions. Site history is one that you can't map and put in a report unless you go to spend the time there. So we've heard from Brad and from Michael how much what has happened previously on a landscape will impact the way that it works today, the way that it might work in the future. So even with all these physical parameters, understanding the human side, what that history has been, has everything to do with our path forward. In general, if I'm going to paint a big picture, I would say from a nature-based solutions perspective, I'm going to go with Roland's approach of 3 words right here. I'm going to borrow it. Preservation of the places that perform awesome. Those great resources where important processes happen, preserve those first. Restore areas that did have capacity or could have capacity to be important parts of the landscape, and maybe do some creation of features in certain areas that can do some important things for us as well. So preservation, restoration, and creation. And I'm going to throw up this book. I'm going to go a little bit philosophical here. Author named Erica Gies wrote a book a few years ago called Water Always Wins. I feel like that one telegraphs the concept behind the book pretty darn good. So we can have, again, the best of intentions, and we try to stand between water and gravity. We usually get disappointed. But the main thought of the book, not to co-opt a phrase that Brad actually had of slow water, her idea is, you know, in modern society, we like to make water go here and there, do what we want it to do really fast. Maybe we'd get better results if we actually take the opposite approach of slowing things down. Generally, the idea, again, borrowing from the language of the authors, water's true nature is to flex with the rhythms of the earth expanding and retreating in an eternal dance upon the land. Sounds pretty cool. Conventional infrastructure has erased so many of its slow phases, instead confining water and speeding it away. We do that really well, making it go into small spots, getting rid of it fast. But that way of doing things doesn't have to be that way. It's not inevitable. We do have a choice in this. Ultimately, we can ask, what does water want? That understands the broader landscape stories, the people stories, and a whole lot of other processes to really understand what water would want to do. So the general thrust is to restore these slow phases, make room for slowing things down, water availability, flood control, carbon capture, and all of the things that I think maybe don't talk about in professional settings as much, but the awe and the wonder of actually leaning into and exploring an overgrown juniper thicket, or looking at a spring, looking at less vegetation, wildflowers that the Edwards Plateau is famous for. That's stuff that's hard to quantify, but really makes the quality of life all worth it. Let water be water. If you look at the future, talked about the future, in an intermediate scenario, we're right here, right now. In an intermediate scenario, our landscape 60 years from now will actually feel like one that's a little bit to our south, nothing extreme, if we do some good things. If we don't do those good things, this is more what our expected conditions would be 60 years from now. This is not the Edwards Plateau that we know. So we'd expect similar plant communities, eventually, if there is an equilibrium, to be those along and south of interior Mexico from the border. Well, what does that mean in terms of our iconic plant species here in the Edwards Plateau? For the big tooth maple of the lost maples, lost. For ash juniper, based on its current range, it's ashes. For redbuds, maybe we can pick them up, but you know, those are all actually higher altitude. Redbuds, dead, bud. Pecan, those are getting out of range. They're canned. Bald cypress, they're out of range. Bad cypress. Post oak, more like post-mortem. Wrap it up. This is, I think, the most profound thing that I got out of the AI when I was preparing for this presentation. The future of the Edwards Plateau is not set in stone. Our choices today will shape the landscape of tomorrow.